So as I was saying in the last video before I got cut off, I plugged in 1.2 into the resulting polynomial from synthetic division. I got a remainder of 0, so I took 5 and we put an x squared in front of it, minus 10 equals 0. In case you're curious as to why I use an x squared, I started with an x to the fourth. I did synthetic division on negative 1. I got a remainder of 0, which makes that polynomial x to the third. And doing one more synthetic division got me an x squared. I set that equation equals 0, I solved for x, and I got plus and minus root 2, and these were all my possible zeros. Now, as a reminder, if you can get a polynomial to a quadratic, which is what we have here in the yellow box, then you can use quadratic solving techniques and you can get rid of all the rest of the techniques that you know. And you're basically all done with the problem. Now, I don't think I did a great job at trying to communicate how you're supposed to use this technique in the last problem. So let me try again. We have a new problem here, and we have to find all the zeros. The rational root test that I was telling you about the last time says to take p and divide it by q, where p, in this case, would be negative 44 and q would be 13. And I'm going to get a whole list of zeros like we saw the last time. And each one of those numbers is a potential zero for the polynomial. And we don't know if it's actually zero until we either do synthetic division or we do graphing. So let me just go ahead and try out this example with you. I'm going to take p, which is negative 44, and I'm going to list out the factors of it, which are 1 and 44, 2 and 22, and 4 and 11. I'm going to put a plus and minus in front of each one of these because I know that a factor of negative 44 could be a positive 1 and it could also be a negative 44. When I'm ever listing out these potential rational roots, I'm always going to put a plus or minus in front of the factors. So I'll repeat with q, which is going to be a positive 13, and the factors of positive 13 are positive 1 and positive 13. So p over q means that I'm going to take all these zeros in the numerator. I keep saying zeros. I'm going to take all these factors in the numerator, so plus and minus 1, plus and minus 2, and the list keeps on going. And I'm going to divide them by the potential zeros of q. And again, this is equal p over q. Now, my actual list then is going to be plus or minus 1, if I take the 1 and divide it by the 1, or plus or minus 1 over 13. And this is the tedious part. And when we're all done with this, it's going to result in 24 different factors, which is a lot. And it by no way means that each one of these factors, a positive or a negative, is going to be a root on the function. Like I have 24 numbers here in this purple box. There is no way that each one of those numbers is going to be an x-intercept on the function x cubed, 13x cubed minus 11x squared plus 52x minus 44. In fact, 0 of those numbers could be on the graph, or 1 of those numbers, or 2 of those numbers, or 3 of those numbers, but it won't ever be more than 3 for a reason that I'll go into in the next video. The bottom line here, though, is that the reason I set up these factors, this ratio of factors on the constant term and the lead coefficient, is because I'm going to use these numbers and I'm going to use my graphing calculator to check and see if there's an x-intercept at that particular value. Let me rephrase it one more time and then I'm going to let you pause the video so that way you can go in and try to finish up the rest of the problem on your own. All these numbers here are possible rational zeros. A function can either have rational zeros, irrational zeros, or complex zeros. If our function has a rational zero, it has to be one of these numbers on here. If it has just at least one rational zero, then that means one of these numbers is true and a factor of the polynomial. If you can find one, use synthetic division to reduce your cubic equation to a quadratic equation, and then use your quadratic factoring techniques to finish up solving for the remainder of the zeros. There are 3 zeros total. I'm going to let you pause the video now to try the problem. So if you tried the problem on your own and you use your graphing calculator, you probably got this function, which isn't really doing a whole lot for us. But what it tells us is that there's one root right by x equals 1. I could try to zoom out and see if there's anything else here. So I'm doing a zoom fit, which is choice 0 on zoom. And again, it really looks like there's just one x-intercept. It doesn't look like the graph goes through the x-axis more than once. It looks like there's just one time that the graph goes through the x-axis. So let me go and do a zoom standard. And while I'm waiting, I already said that the x-intercept looks like it's at x equals 1. So let me go back to my roots. Let me also show you what the answer is as well. I listed all my roots here. I'm going to go back quickly. I thought that the x-intercept is about 1. So what I can do is I could cross off all the other possible values that aren't close to 1. Like 44, not happening. Same with 22, same with 11 and 4 and 2. And if I look back at the graph, it looks like the number has to be close to 1, which means that 1 over 13 is pretty close to 0, so that's got to be out. 2 over 13 is pretty close to 0. And 4 over 13 is getting closer to half, but not close to 1. 22 over 13 is more than 1, and so is 44 over 13. So it looks like my only possible roots could be plus or minus 1 and plus or minus 11 over 13. And finally, if you did this part, where you actually tried to do the 0 here, so we'll do choice number 2. I'll do my left bound of 0. I'll do my right bound of 1. And I'm going to guess, I'll just leave it as a guess. And let's see what the calculator thinks. It gives me this 0.846. What that tells me is that plus or minus 1 is out as well. So I'm going to guess that the root is 11 over 13. And that was my logic for coming up with 11 over 13 as synthetic division. I could verify this on the calculator by doing 11 over 13, and it's 0.8461, which is what that value was when I did the 0. When I did synthetic division as well on 11 over 13 on the polynomial, I got a remainder of 0 as well. So what that told me is that I got a resulting quadratic, 13x squared plus 52 equals 0, and I solved for x here, moving the 52 to one side, making it negative, dividing by 13, getting me negative 4, and I got plus and minus 2y. These were all three zeros of the cubic equation. Hopefully now it's a little bit clearer as to how we use the rational zero theorem to be able to find zeros of a polynomial without really using a graphing calculator to find that for us explicitly. These last two problems won't be too bad, I don't think. We want to find if the binomial has a factor. We want to find if this binomial is a factor of the polynomial. So what I'm going to do is I'm going to set 8x plus 6 equals 0. I'm going to do x equals negative 3 over 4. I'm going to list out the factors here. And if you're thinking, hey, is he about to do synthetic division? You're darn tootin'. That's exactly what I'm going to do. Now, what I want is if that binomial really is a factor of the polynomial, I should get a 0 here. If I don't get a 0 there for the synthetic division as a remainder, then that means that the binomial is not a factor of the polynomial. So let's see what we get. if I take, oh, that's a terrible looking 8. But feel free to go on without me here. Take 8 and multiply it by negative 3 over 4. I'm going to get negative 6. Feel free to use a calculator for this part. Negative 50 and negative 6 will be a negative 56. And when I take negative 3/4 of negative 56, I believe I'm going to get a positive 42. 6, 4, 14 times 3 is a, yep, positive 42. And that's going to be a 16 here. When I take 3/4 of 16, I believe that's going to be 12, and it's a negative 12, which is going to be about negative 8. And when I take negative 3/4 of negative 8, that's a positive 6. Haha, I get 0. And what does that tell me? Not only am I going to get out some plates and cake and celebrate, but that also tells me that 8x plus 6 is a factor of f of x. Again, if you don't get a 0 for a remainder when you're doing the synthetic division, that means that you do not have a factor of the polynomial. Last problem. Feel free to pause the video now to try it on your own. And if you tried it on your own, you get 5x minus 2 equals 0. X has to equal 2 over 5. And if I did synthetic division on 2 over 5, I do indeed get out the lucky 0, which means, is this binomial a factor of the polynomial? You're darn tootin'. Thanks for watching, guys.